Today I'm going to be talking a little bit about my project, my EDP project that I have been working on with my teammates Nyla and Fatima. I'm going to go a little deeper into what I have learned over the semester, the tasks that I have completed, with the tools and techniques that I've used, and what our plan collectively as a team is for this upcoming semester to be able to achieve our goal. So our project that we're working on is accurate table retrieval from unstructured sources. And what we are attempting to do, or we're attempting to build on, is when you enter a query and you get a list of tables which are ranked that are most relevant. And what I mean by building on this work is to take this work that they have done and understand exactly how it works, and then creating some of our own features that we are able to introduce to the learning to rank model for it to be able to retrieve tables with a better ranking. And I'm going to go into a little bit deeper what I have completed in this past semester, week by week. So that for that first week that we had started working on this project, some of our tasks included for us to do research on the ad hoc table retrieval using semantic similarity. And this is a paper by Zhang and Balog, and to go through it and understand this paper and some of the terminology used in this paper. For example, list-wise, pair-wise, ranking, learning to rank, and being able to understand what this paper is talking about for us to be able to study that further on. For the second week, we were able to go in and do more research and really go deeper into this whole topic. And the way we did this is going through the research paper, going through it in a very detail-oriented manner, so that we were able to understand exactly what the work that was accomplished by this paper. And this was important because we are aiming towards building on this work and adding new things to this existing work. So it was important for us to go into detail and understand this. And some of the things that we focused on was understanding the different types of learning to rank algorithm. For example, point-wise, pair-wise, list-wise, and what a supervised model was, what an unsupervised model was. And we went through this in detail. The paper has a table with the different features that they have used throughout the table to do the semantic relevance, to do the semantic matching and the relevance model. And these are the features that the learning to rank model has used for it to be able to map what is most relevant, and going into those features and understanding what those features do, like IDF and HITSB, and goes further into detail about what these features actually do. For week 3, we focused, which was part of the task of week 2 also, was to start getting our hands dirty and going through the Lemur project, which was the rank-lib library. And essentially, this was a tutorial on algorithms and learning to rank algorithms that we could go through and match them, go through and run them in our own computers with data sets. So we went in, downloaded the data, and went through every single algorithm, which included mart, ranknet, rankboost, add rank, lambda mart, listnet, and random forest. And we went through all of these algorithms and ran them and kind of compared their data and the output that we had gotten for every algorithm. And something that I did was take one command and run it for all of these 8 algorithms to see which was performing better. And something we were focusing on was high capability and an overfitted model. if and we were checking whether the test data output, it was the pointwise and the pairwise techniques. It has no effect on it. And something about all of these three metrics that I learned during this week is that they're all essentially how these algorithms, the performance is ranked. So the first is the NDCG, which is the ranking equality. The map is essentially these are all ranking documents. Essentially, all of these are ranking measures that are used to rank documents in the relevance to the query, the relevance of a query to the table, and vice versa. And I guess this leads us into week number 5, which was our final. This leads us into week 5, which was our final week that we had worked on for this semester. And throughout this week, our major focus was for us to be able to implement some of these features and reproducing some of the results from this, some of the results from the paper by Zhang and Belog, and taking it and reproducing that work for us to be able to understand exactly how some of these features worked. And the first step to this was being able to parse data. And I didn't mention this in the beginning, but the authors of the paper have created this 1.6 million table, I guess, repository, which has all of these tables, which are unstructured. And so the first thing that we had to do was take this data and parse it. And this was very new for all of us, because I have not specifically, I guess this was new for everybody, but for me, I haven't done Python before, so this was a little bit new for me. And so downloaded PyCharm, and we started working with the Pandas library for us to be able to parse this data. And we were able to successfully complete this. And further going into re-implementing some of the features that we implemented were, and we are still currently trying to perfect these and being able to exactly get what the results of the paper has gotten, where IDF hits B, Y rank, and a feature that I focused on was Y rank. And this is the ranking of the Wikipedia tables, from ranking of the Wikipedia tables. And in order for me to do this, I did a lot of research on the internet about how this is done, and I was able to kind of take bits and pieces of different sources, and being able to start working on the feature myself. And I face a lot of difficulties with this because, again, starting to work with Python, and actually understanding how to implement this feature. And I'm still currently working on this, and hope to continue to work on this over the break. So next, I'm going to go into some of the tools that we use. And the first tool that I've used is ranklib, which is that library for us to run all the algorithms, the learning to rank algorithms and test and see which one was performing the best. Another PyCharm for Python on the internet, because we did spend a huge amount of time on researching this semester, which helped us to better understand what our project was with the concepts that we were working towards, GitHub. And some new techniques I learned so far, one of the major ones being Python. It is a work in progress as I'm still learning. Something else that I've learned and haven't done this before is working working with large data, and like I mentioned before, the 1.6 million tables that we worked with, and the Python libraries. Again, this is a new technique. Some of the ones that I worked with was pandas, I guess is used for data frames, and creating data frames for us to parse tables, the JSON tables, in the format that they were in. Beautiful Soup is a Python module, which is like used for data scraping. So the potential plan for the upcoming semester, and like I've mentioned before, we are hoping to build on this work from this paper, and the way we are planning to do this is on this PowerPoint here. You can see a list of all of the features that this paper has incorporating while working with while creating their model and these features. And what we want to do is take these features and understand them and really go into detail, which we have focused a lot of our time in this current semester doing. And in this upcoming semester, we want to brainstorm new features that we can implement, which would be relevant to this project, and new features that we can use for us to be able to get a better semantic relevance model with.